Welcome everyone to this section where we discuss the curriculum of Practical Introduction to NLP course. So the course is divided into 4 modules, and module 1 will go over dataset creation, where we'll see how we can create new datasets using 3 different methods. One is using coding and one is using without any code with tools like ParseHub, and the other thing is actually using GPT-3 to create novel datasets. And when using coding, we'll use Beautiful Soup to parse data from web pages. And in module 1, we'll also discuss more on TF-IDF and other things. We'll look into each of the module in detail in a minute. But before that, let's understand on a high level. So when it comes to module 1, essentially we are looking at converting any text into vector using sparse vector algorithms like TF-IDF, etc. Everything will be evident to you soon once we get to that section. And module 2 will focus heavily on data visualization. So how can you convert any document or content that you have into a 2-dimensional or 3-dimensional vector, and how can you visualize it in a 2D grid, etc. For example, you can put together movies and directors together and kind of see the associations, etc. And we will also look at few practical applications of word vectors and NER, named entity recognition. We'll see what it is in the future. And module 3 will focus heavily on more advanced algorithms to convert text into a vector. By that I mean you can take any sentence, word, or a paragraph and convert it into an array of numbers. That's what I mean when I mean vector. And what's the advantage of converting text into vectors is that now you can treat it as a n-dimensional data point. Now you can do comparisons of how close two things are with respect to each other, etc. So you can do all kind of, just like if you have 2D points mapped, you know the distance between the points and you know how far one point is from another when compared to another point, etc. Similarly, you can do all these kind of comparisons once you are able to convert any text into a vector of n dimensions. And the biggest thing to remember is that we'll see how we can do the same vectorization of any text using TF-IDF in module 1 and advanced algorithms like sentence transformers in module 3. So module 1 and module 3 will complement each other, where we'll see how module 3 has evolved to be better than what module 1 algorithm uses. So the same things that we are going to do in module 1, we'll do it better in module 3. And module 4 specifically focuses on teaching advanced language models like GPT-3, how we can use them and how we can leverage GPT-3 to build applications. And the biggest thing is that we are going to see how we can convert code into an API. It could be GPT-3 code. Once we develop something in the GPT-3 dashboard, how can we convert that into an API? So for those who are unaware, GPT-3 is an advanced language model for doing text generation tasks. By that I mean like paraphrasing and other things, etc. And module 4 is very interesting because we are also going to see how we can go from algorithm to API, and then from API to a product using no-code tools like bubble.io. On a high level, we are going to cover all these topics: dataset creation, data visualization, and using models to build some algorithms and also do production deployment. let's get into each of these modules and understand them a little bit better. So in module 1, the first topic that we are going to discuss is dataset creation. Of course, there will be an introductory lecture after this one on basic terms in NLP and what are the different terms like NER, named entity recognition, and several other things like co-reference resolution. All these things, what do they mean? So we'll understand NLP and its various subtopics. Then we'll introduce the goal of building our MoviePro.ai product, the NLP powered application for movie production houses like Universal Studios, Disney, etc. Then we will see 3 different methods to collect datasets. One is using code with tools like with libraries like Beautiful Soup, and the other is using no code tools, just scrapers like ParseHub, and we'll see what are the advantages of them when compared to using code. And we will also take a brief look at how you can generate novel datasets using advanced text generation algorithms like GPT-3. And we'll also build our first UI with Streamlit, where you can search for similar movie plots, etc. And in module 1, the second topic that we are going to look at is TF-IDF, term frequency inverse document frequency. Don't worry if you don't understand this term at all. We are going to see what it does. Essentially, it is going to convert any given document, text or movie plot in our case into a vector, that is n-dimensional number, a list of numbers actually. And you will see how a single algorithm like TF-IDF can be used to extract important keywords from the movie plot or text, and how we can summarize any movie plot or text, and also find similar movie plots using TF-IDF algorithm. So extracting keywords, doing summarization, and finding similar movies, all these things can be done with a basic algorithm like TF-IDF. And the biggest thing that we are going to see is that no need to remember any mathematical equations for TF-IDF. We are going to very intuitively build a TF-IDF and understand all the things that are necessary, the mathematical equations, etc., and arrive at the final equation, all using intuition. And module 1 will have a project where we calculate sentence diversity using n-grams. We'll get introduced to the idea of n-grams, and we'll use a pre-trained paraphraser. You don't need to really understand that, you can just use the code. But the biggest thing is that as paraphraser generates multiple sentences, we will see how we can rank them based on the most diverse ones using n-gram approach. And module 2, the first section involves visualization. So most people do not understand, but visualization is a very, very crucial aspect of model building, where you can easily identify any anomalies or bad data points that we collected. So we are going to convert all the movie plots. Each movie plot will be converted into just a 2D number, 2-dimensional number, or 3-dimensional number, and we are going to see it on a grid. So it will be very easy to see which movie plots are close to each other, etc. And this is where we get introduced to sentence transformers that can convert a full document into a vector. And we'll also see how we can have 2 different categories of text. That means we can plot both movie plots as well as the directors and their descriptions on a single plot. And we will see the power of visualization, where you can see for a given movie which director is closest in terms of the description of the director, etc. And you can kind of see how on a 2-dimensional plane you can easily see for a given movie who are the potential directors you need to evaluate. Similarly, you can do the same thing with cast and crew. And the module 2, the project in it involves adapting a movie plot into another country or locale. Simply what that means is that a lot of times movies are dubbed into another language. For example, a Hollywood movie in English could be dubbed into Hindi, Bollywood movie. So what happens is that you need to do something called as localization, which is changing all the places. If Los Angeles is mentioned, perhaps you want to use Delhi or Mumbai. Similarly, if you're dubbing it into another region, maybe China, you need to use similar Shanghai or something like that. So how can you automatically use word vectors and convert these names of the people as well as locations and other things like currency, etc., into a different locale, basically doing something like dubbing and also converting the names, places and other things. It will be a good utilization of both named entity recognition algorithm as well as word vectors. And module 3, whatever we have done with TF-IDF, which is building building a recommendation system for identifying similar movie plots to a given movie plot, and all those things, extracting keywords from a movie plot, all those things we are going to do with advanced algorithms like sentence transformers. And we'll also do topic modeling on movie plots. So automatically can you categorize movies into their genres, like horror, romance, comedy, things like that? Can you automatically group all the movies that we have into these different segments? That's what topic modeling is. We are going to see it in detail. And module 3 will also see an interesting use case with sentence transformers as well as word edit distance algorithms, where you can give a phrase answer or etc. for a quiz, and if students try to answer your quiz and if they enter an answer, can you automatically grade them and get the score of how close the student entered answer is to your original answer. And in module 4 we will learn one of the most advanced text generation algorithm called as GPT-3, and how you can use the GPT-3 API to build products on top of that. So you'll be equipped with building new SaaS apps using GPT-3, and we'll go from converting code into an API, and that API will be converted into a production app with no code tool like bubble.io. Awesome. I hope you got a very strong understanding of what 4 of the modules stand for. So in short, we are going to cover everything from TF-IDF to sentence transformers to GPT-3 to deployment. And when it comes to topic, we are going to touch upon everything from data creation to data visualization to building algorithms using models to again deploying a production app. That's about the curriculum in short. Hope you are as excited as I am, and I'll see you in the next section. Thank you.